Hello there, welcome back. This is actually part 4 in 3.7, but it's part 2 of the inequalities because the first two were about equations, and then we had an equal sign, and now this is about solving and graphing absolute value inequalities out of chapter 3, section 7. So here we go. Start with this if you would. Hit pause if you need to and get this part down. That's what we're going to talk about. How do you solve and graph if you have a greater than or a greater than equal to sign like this? In the previous videos we talked about what to do when we had a less than sign, and we looked at how that created an and compound inequality relationship. And now we're going to see what happens when we have a greater than sign, because something's a little bit different. So let's start with this really simple one, like let's just say we had the absolute value of some number x is greater than or equal to 9. Alright, so in the middle, let's recopy on our note-taking template. Let's recopy that. Absolute value of x is greater than or equal to 9. So over here in the description again, we're just putting our thoughts and our ideas, and hopefully these things you'll refer back to when you're trying to practice this on your own in class. Question you want to ask yourself. Okay, you want to ask yourself what values after the absolute value is taken are greater than 9. In other words, now that's just my language trying to explain what you should be thinking here. You should be looking at this wondering, what value could I put in for x to make that true? All right, well, let's just think about that for a moment. Okay, let's think about that. I'm going to change colors here. Let's consider, if x were 10, would this be true? 10, absolute value of 10 is greater than 9. If I take the absolute value, yeah, there it is. That's true. So that's a solution. Okay, 10 would be a solution to this. What about 11? If you take the absolute value of 11, would that be greater than or equal to 9? Yes, it would. That's true also. So that means 11 is a solution. How about 9 itself? 9 would be a solution. So I think if we look at this on a number line, it might help it to make more sense. So if you would sketch a number line on there, and let's just put 9 as a boundary here, and let's consider, would 9 be a solution? Is this true right here? Is the absolute value of 9 greater than 9? Yes, it is. So we would have a dot here on 9. Now take a look at this one, the absolute value of 10. That means that 10 was a solution. So where I had 10, you'd have a solution there as well. And where I had 11, you'd have a solution there at 11 as well. What about 10.5? 10.55, 10.56, 10.57. So all of these points go in this direction. As I go larger and larger, I'm going to continue to have solutions, because these are all values where the absolute value of x is greater than 9, greater than or equal to 9. But let's consider the other side of the equation. What if I had the absolute value, I'll write it over here, the absolute value of negative 9. Would negative 9 be a solution to this as well? Well, so here's the question you're wondering. Would that negative 9 be a solution for this? Well, what is the absolute value of negative 9? It's positive 9. Is that greater than or equal to 9? Yes, it is. Another smiley face. So over here at negative 9, I would have another solution. What if x were negative 10? Is that greater than or equal to 9? I'm wondering. Now this is the thinking process that you're going through as you consider what the possible solutions are. Well, the absolute value of negative 10 is positive 10. Is that greater than or equal to 9? Yes, it is. Therefore, this would be a solution over here at negative 10. As well as all of these values, I would hit negative 11 and negative 12 and all the fractional decimal values in between there. Okay, those are also values where x is greater than or equal to, sorry, the absolute value of x is greater than or equal to 9. So essentially what we have, this area right here represents all values x less than or equal to -9, right? If I were to figure out the inequality for this, that's what it is. It's all values less than or equal to -9, -10, -11, -12, less than or equal to. This area here represents all values x greater than or equal to 9. So we have a or conditional statement here where you could have a value to the left of -9 or to the right of +9 to make this a true statement, which is a solution, which is what you're looking for there. Okay? So basically, the conclusion here is that a greater than or equal to sign creates an or type of inequality, which we learned when we graphed compound inequalities last week. Creates an or inequality. So as I solve these, you're going to have to whittle it down. And notice on this one right here that I reversed the sign when I took that negative value, and you're going to have to do that as you see in the next problem here. Okay, so keep those notes near because all the notes kind of fit together for you. Here, let's take a look at one more problem. Here again, make sure you're hitting pause, thinking, rewinding, reviewing things that maybe don't click the first time for you. It's okay if it doesn't. That makes you more normal than you realize there. Probably shouldn't make sense for most of you the very first time. And it's that perseverance and determination which you help get through when it gets hard here. Let's try this one right here. Let's say I have the absolute value of 3D is greater than, 3D minus 7 is greater than 28. So I'm going to do 3D minus 7 is greater than 28. All right, so the first thing I want to do is recognize, that's an E, recognize, okay, that greater than means it's going to be an or inequality. In other words, somehow you're going to end up with, now it's going to be an open circle since you have a greater than, but it's not equal to. And you're going to have it going this way as well. Now allow me to use the visual over here to help show you. Basically what you have here, okay, is imagine that's 28. So all of these solutions are where 3D minus 7 would be greater than 28. Okay, just like we did in the previous one. All right, and all of the solutions to the left over here, these represent the solutions where 3D minus 7, okay, is less than negative 28. Because remember, when you take that absolute value, it flips over to the positive value when you take it away. So notice right here that we have created basically the two inequalities that you're going to have to create here. Again, you have to have this isolated down to the absolute value like we did right there. So you now have 3D minus 7 is, I'm going to do this one first, is less than negative 28. Or 3D minus 7, okay, is greater than 28. So I did this one first, then I did this one. Now you're just going to solve both of these problems here. Add 7 to both sides to solve it. 3D is less than negative 28 plus 7 is negative 21. Okay, go ahead and divide that by 3. Do not switch the sign here because you're not dividing by a negative. So you have D is less than negative 7. Here you're going to add 7 to both sides. 3D is greater than 35. Divide that by 3. Divide that by 3. You have D is greater than 35 thirds. 3 does not go in there evenly, so let's change it to, I believe it goes in there 11 times. That would give me 33 and 2 thirds. So your solution is D is less than -7 or D is greater than 11 and 2 thirds. And the graph would look like, here's -7, open circle going this way. Here is 11 and 2 thirds, open circle going this way. And voila, you've got the solution. Basically, here's the solution and the graph as one. Okay, so it's crazy, I know, but you just have to do it and keep doing it. Look in your book, review the videos to hopefully help you get toward mastery, and let's do it. See you soon.